Welcome to Chapter 7. In this lecture, we'll talk about systems of equations and inequalities. So let's start with the first one, systems of linear equations which contain two variables. So in this section, you should be able to solve equations by graphing, by substitution, and by addition. Finally, identify the inconsistent systems of equations that contain two variables and express the solution of a system of dependent equations containing two variables. So let's start with system of linear equations. So what is a system of equations? System of equations are the ones that contain either two or more linear equations that make up two or more variables such that all of the equations on the system are considered simultaneously at once. So there are three types of linear systems that we consider. First is an independent system, which generally contains one solution pair, an inconsistent system which does not have a solution, and a dependent system which has infinitely many solutions. So in an independent system, all of the lines will intersect at one single point. That intersection point becomes the solution. In an inconsistent system, all the lines are parallel and they will never intersect. In a dependent system, these lines are coincident and they are on the same line. They are all the same line, so every coordinate will have the same solution to both the equations. So the first one that you see here, you have two lines that are intersecting at this point, so this is an independent system. This is an example of an inconsistent system which generally has two lines that are parallel to each other and they will never intersect each other. And this is an example of a system which is dependent where both the lines are on the same line. So both lines co-intersect each other. So when they intersect here across every single point across the curve, so this is called as a dependent system. So how do you solve the system of equations? So given a system of linear equations and an ordered pair, how do you determine whether the ordered pair is a solution? First, we substitute the ordered pair into each of the equations in the system and determine whether the true statements result from the substitution in both the equations. So if so, then the ordered pair is a solution. For example, here they're asking us if 8, 5 is a solution for this. First, we substitute 8 here into the first equation. So 5 times 8 minus 4 times 5 equals 20. 5 times 8 is 40 minus 20 equals 20. So 20 equals 20. So this is a true equation. So we can say that for this particular solution it acts up. Next you have 2x plus 1 equals 3y. 2x is 8 plus 1 equals 3 times 5. You have 2 times 8, 16 plus 1 equals 15. 17 is equal to 15. So which is false. So which means that, notice that it is true for the first one, it is not true for the second one, which means that this here is not a solution. So the point that you substitute should satisfy both the equations. Only if both the equations are satisfied, we can say that the given ordered pair is a solution. So how would you solve this by graphing? So graph both the lines and find the intersection point. So this is how you can solve by graphing. You've already seen that graphing method before, so try it on your own. And let's come to the next method by substitution. So you have two equations and we try to substitute. How do you do substitution here? First, convert this equation into this manner where you only have y on one side and everything else on the other side. So how do you do that? First, reshuffle the equation. You have 4x plus 2y equals negative 10. 2y equals negative 10, negative 4x. Y equals negative 10, negative 4x by 2. So if you further solve this, you get minus 5 minus 2x. So you have, from the first equation, we have y equal to minus 5 minus 2x. Substitute this into the second equation. Remember that never substitute it back into the same equation, substitute it into the second equation. So when do you substitute it into the second equation, we have 3x plus 9 times negative 5 negative 2x equals 0. Now find the x value. Solve this to find the x value. So 3x minus 45 minus 18x equals 0. So 3x minus 18x is minus 15x. So minus 45, push it to the other side. It becomes 45. So x becomes 45 by negative 15. So negative 15, so this becomes 3. So you end up getting negative 3. So here x equal to negative 3. Substitute this back into this equation here and find the value of y. So y becomes negative 5, negative 2 times negative 3. You have negative 5 plus 6, so it becomes 1. So for this, the ordered pair is minus 3, 1 is the solution for these two equations. So this is how you solve by substitution. So use the same principle now. Pause the video right here and try to solve this problem. Next is the process of addition method. So let's try this method here. You have two equations, 5x plus 9y equals to 16 and x plus 2y equals to 4. So let me put it into a new page. You have 5x plus 9y equal to 16 and x plus 2y equals 4. So how do you do the addition method here? In the addition method, we have to choose which one we want to eliminate. For example, let's say if I want to eliminate x on both of these, so I want to eliminate x first. So we decide which one we have to eliminate and note down the coefficient of that one here. For example, here the coefficient for the first one is 5 and the second one is 1. So multiply the first equation's coefficient with the second equation in total. Multiply the second equation's coefficient with the first equation completely. So remember, we're basically multiplying those coefficients, and write down, multiply the coefficient with the value and try to find the equation now. So it becomes 5x plus 9y equals 16, and for this one it becomes 5 times x, you have 5x plus 10y equals 20. So now we have both the equations. What do we do now is that for the second equation, multiply -1. So when you multiply -1, so you have the first equation. Remember that first equation we are not changing anything. So for the second equation, multiply -1. So you have minus 5x minus 10y is equal to -20. Now add both the equations on each side. So on the left side, add the equation. So 5x plus 9y minus 5x minus 10y equals to 16 minus 20. So plus 5x minus 5x gone. 9y minus 10y becomes minus y equals minus 4. So minus minus gone, you get y equals to 4. So now we have the y equation. Substitute this in any one of the equations. So the first equation or the second equation. So let me choose the second equation because it's simpler. So x plus 2y equals to 14. So x plus 2 times 4 equals 4. X plus 8 equals 4. X equals 4 minus 8. It becomes -4. So the equation answer for x comma y becomes -4 comma 4. So this is the method for solving the problem. How do you solve? First, we choose the one that we have to eliminate. So here we are choosing x to eliminate. So we write down the coefficient for each of them, and we multiply one's coefficient with the other equation. So for 1 here, we are multiplying it with the first equation. 5 here, we are multiplying it with the second equation. Write down the equations once you multiply them, and multiply -1 to the second equation, and finally add those values and finally get one of the values. Substitute that back into any one of the equations and find the rest of the values, which gives you the ordered pair for the given set of equations. So use the same principle now. Pause the video right here and try to solve this problem. Again, pause the video and try to solve this problem. Now, in the next one, let's try and identify inconsistent system of equations containing two variables. So notice that this is an equation where you have 2y minus 2x equal to 2 and 2y minus 2x equal to 6. Now, notice that the coefficient here, let's say we are eliminating y here, then both of them are 2, so we have to multiply both with 2. Then you still get the same equation. You have 4y minus 4x equals to 4 and 4y minus 4x equals to 12. And if you multiply -1 to the second equation, you get 4y minus 4x equal to 4 and minus 4y plus 4x equal to -12. So when you add both the equations, you have 4y minus 4y minus 4x plus 4x, 4 minus 12. So plus 4y minus 4y gone, plus 4x minus 4x gone. So it becomes 0 equals -8. this here is a false equation, so false answer. So when you get a false assumption at the end of the system without having to solve the problem, this here is an example of an inconsistent system. So if you get one solution, so we call that an independent system. If you don't get one solution but rather get a false statement at the end, we call that an inconsistent system. You don't get a solution but you get a true statement at the end. So here notice that this is a false statement, but in case you get a true statement, that is an example of a dependent system. So if it is one solution, independent. If it is false statement, inconsistent. If it is a true statement, dependent. So these are the three classes by which we can classify the equations. So use this principle now and try to solve this problem here. So for example here, let's say if we are eliminating y here, we have minus 3 here and y here. So multiply it with negative 3, multiply it with 1. So you get y minus 3y plus 6x equals minus 15. Minus 3y plus 6x equals minus 15. Now when you add both the equation, multiply the second one with negative 1, and the equation becomes minus 3y plus 6x is equal to negative 15. The second equation becomes 3y minus 6x equals to 15. Add both of them, you have minus 3y plus 3y plus 6x minus 6x equals minus 15 plus 15. So minus 15 plus 15 get cancelled, minus 3y plus 3y, 6x minus 6x. So you get 0 equal to 0. Notice that this is the true statement. So this is an example where you get a true statement, so we can say that this is a dependent system. So this is how we can determine whether an equation is a dependent system or an independent system. Now, how do you use this system of equations to investigate profits? So one of those, we use a revenue function. Revenue function is the function used to calculate the amount of money that comes into the business, and it can be represented by revenue equals to xp, where x is the quantity and p is the price. So the cost function is the function used to calculate the cost of doing business, that includes the fixed costs, rent, salaries, variable costs, and utilities, such as utilities. Now the point at which both the lines intersect is called as the break-even point. So you have two equations here, r equals to 20x and c equals to 12x plus 30. So they're asking us to find the break-even point. Basically they're asking us to judge where the points will come together. So one way of doing this is to take both the equations here, so 12x plus 30 and 20x. So here we are trying to find both of the common points where the break-even point comes in, where both of them meet, which means that the cost is equal to the revenue at break-even point. So which means that you have to basically take into consideration that c equal to r equal to y. So now substitute y equal to 12x plus 30 and y equal to 20x. Now solve for the equation. How would you solve it? Again, multiply negative 1 to the second part of the equation. You already have the same coefficient. So when you multiply the negative 1, you get y equal to 12x plus 30. And the second equation becomes minus y equals to minus 20x. Now add both equations. Y minus y equals 12x plus 30 minus 20x. So y and y get cancelled. 12x minus 20x becomes minus 8x plus 30 equals 0. Minus 8x equals minus 30. X equals minus 30 by minus 8. So x becomes equal to 30 by 8. So 30 by 8, 8 3s is 24. We have 6 left, and 8 7s is 56, 4 left, so you have 3.75. So x equal to 3.75. Here we are talking about the break-even point. So the break-even point here is the cost and revenue, so this is the money, so 375. So at $375, if they sell the product, then the revenue will be equal to the cost. So for it to become profit, so if you want to sell it to a profit, you have to go over this price. So only then we can we can make sure that we can make some profit. If the price is less than this particular product, this price, then it will be a loss. So use the same principle now and try to solve this problem. So next, what is given here? You have granola that costs $4.50 per pound and assorted nuts that cost $7 per pound. How many pounds of granola and nuts are needed to make 7 pounds of trial mix that costs $5 per pound? So notice that here, for this to be made, you have to make 7 pounds of trial mix that costs about $5 per pound. So cost per pound here is $4.50. And assorted nuts here, so this is granola. So the nuts here, assorted nuts here, is about 7 per pound. So how many pounds of granola and nuts are needed to make 7 pounds of trial mix that costs $5 per pound? So they're asking us to how many pounds of each are needed. For example, let's consider that the amount of granola is X, number of pounds of granola is X, and the number of pounds of assorted nuts is Y. So 4.50X plus 7Y must be equal to 7 pounds of trial mix at $5 per pound. So 7 pounds for $5. So you have 4.50X plus 7Y equals 35. So this is the equation that we have made. Now they are asking us to find out what would be the value of X and Y each. So we have to solve for this X and Y each and try to find out the value for each of them. So now we found out that this is the price equation. What would be the equation for the total amount of weight? Notice that if this is X and Y, we are making a total of 7 pounds, which means that X plus Y must be equal to 7. So we have two equations now, X plus Y equals to 7 and 4.50X plus 7Y equals to 35. So X plus Y equals 7 and 4.50X plus 7Y equals 35. So take the simpler one to eliminate. So we have Y here. So here it is 1 and here it is 7. So multiply it with 7 and multiply this with 1. So that becomes 7X plus 7Y equals to 49. And this becomes 4.50X plus 7Y equals 35. So multiply the second equation with negative 1. So you get 7X plus 7Y equals to 49. And negative 4.50X negative 7Y equals negative 35. So add both equations. You have 7X plus 7Y minus 4.50X minus 7Y equals 49 minus 35. So plus 7Y minus 7Y gone. So 7X minus 4.50X becomes 2.50X equals 49 minus 35 becomes 14. So X becomes equal to 14 by 2.50. So let's calculate the value for 14 divided by 'So that becomes 5.6. So X value is 5.6 pounds. Substitute this into any one of the equations here. So substitute into the first equation because it's simpler. So X plus Y equals 7. So X is 5.6 plus Y equal to 7. So Y becomes 7 minus 5.6. So that becomes 1.4. So here, granola here is 5.6 pounds and assorted nuts is 1.4 pounds. So this is how you can solve an application problem when you have this type of an issue here. In the last problem, how would you write an equation here? So you have a meal ticket at a circus costs $4 for children and $12 for adults. If 1650 meal tickets were bought a total of 1200, how many children and how many adults bought a ticket? So let's consider that the ticket for the number of children who bought the ticket is X, the number of adults who bought the ticket is Y. So then when we have 4x plus 12y equals 14,1200 in total amount. Now the total number of tickets that were bought were 1650, so which means x plus y equals 1650. So this is how we have the equation. So this is the total number of tickets, and this is the total number of cost, total amount of cost per children and adults combinedly to give you the total amount. So use these two equations now, solve the two equations and find your final answer. Pause the video and try to solve this problem. So with this, we end our lecture on system of equations.